Hello, my name is Ernesto Fiaggio. I'm doing a project for the class Embedded Linux Operating System at FIU. I'm a computer engineer senior student. The class is being taught by Alexander Pons and it's the final project. My project will be using the beaglebone, as you can see here, that you can acquire it from, purchase it from $45 most of online. What I'm going to do is using the GPIOs here on the pins of the beaglebone to toggle an LED. So I'm gonna build a program, a C program, so that is gonna be able to toggle the LED. Here I want you to take a closer look to the circuit. It's a pretty simple circuit. Here you can see a transistor. I'm using a transistor in order to not pull in too much current from the LED, from the beaglebone. I mean, here I got a 10K resistance connected to the base of the transistor. Here this wire will be to an input to a pin of the beaglebone. This will be the output of the beaglebone that we're gonna toggle C program. Here is the power that we are getting, the power from the beaglebone as well, from a pin that takes the power from the USB. And here we can see the LED, which is connected in series to this 100 ohms resistor that is connected to the collector of the transistor, and the power is being applied to the LED. So it's a pretty simple circuit, just to trying to prove a concept that what you can do with the beaglebone. So in brief, I proceed to show how to access the beaglebone pins on the through SSH to the board.
Okay, so now I'm gonna show you how to access the GPIO pins, um, and then modify the value, configure for input or output, and export and map it to a file. You know, Linux is all in Linux is a file, so you have to mount a pin as a file. So there you can change the value, you can change the direction if it's an input of an output. Here we shows the pin. See if you can see there. It shows the pin pin 11. Here you can see as a general input or output is 030. This number right here is the bank, and this is the pin that is at. So you multiply this by 32, since every bank has a 32 pin. So 0 by time 32 is 0 plus 30 is 30. So you should map it to GPIO 30. Well, when you I'm now gonna show you how to perform that. So now we go to CD class. I mean CD sys class and to GPIO. As you can see here, we don't have a GPIO 30, so we are not right now we are not able to write or set the pin as an input or as an output. So that's what we're talking. So you have to calculate that little calculation that I show you there. So you do an export, you do echo 30, export. So you have and now if we do an ls, we can see that we got a new folder there that is called GPIO 30. We get into our folder. So here are the files that we can modify. Let's see what we have in direction. We have set it as an output already, so that's what we want. Let's say the value that it has, 1. We want to set it to 0. So now our LED should be off. If we do echo 1, echo 1, value should be on. So this is for accessing the pin and setting a value, so we can turn on LED on and off. So I wanted to show you this first in order to now I'm gonna open Eclipse, and I'm gonna show you a little program that I make in C, just for you to get an idea what you can accomplish with this. And I did a little program in C that that toggles the LED on and off the an amount of time that you want. So now here's the code that I built for toggle and the LED. Here you can see some includes that are necessary for what we're about to do. This is my main, just pretty simple, just calling the toggle LED function. This is the prototype. I got it all in one file since it's a real simple program. Here I create a file pointer. Here I create some values where I'm gonna store this. Here I pass the pin that we wanna work on and the times we wanna toggle the LED. Here we pass the route where the GPIO pin value file is and the direction. See, I'm just using the pin so I can change the pin and don't have to like change this. Here we open the to export file appended binary. If we cannot open, we print an error. Then we copy the value on GPS string to set value and write it to a file here, a character, 2 characters, and the file handle. We close the file, so that's when actually the file is written. Here we got the f handle again. What we want to try to open now is the direction. We want to set it as an output. See, we put it set output 3 characters. Set value that because I'm using the same handle for the file. Since I open it and closing it, I don't have to declare like a lot of here. So when actually the toggle happens, I multiply times by 2 since we want 5 times on. For example, let's say we choose 5, like I have chosen here. If we want to have a 5 times on and 5 times off, so that's 10. So we open the file. If we cannot open, we're gonna set the value. So here we're basically basically doing if it's an odd number, we put it to 0. If it's an even number, we put it to 1. So if it's an odd number, we set off the LED. If it's an odd even number, we set on the LED. Here we write to the file the value. We close the file and put the function to sleep for 1 second so we can see the link, the LED blinking. since you know the CPU process are really faster. Otherwise, we wouldn't see the actually the LED blinking. Here now, as you can see, I'm at the beaglebone. I was going to show you how to clips, how to compile this with the clips as well, but I run into an issue with the clips and I didn't want to fix it because it's a lot of work. So I had the executable file already built, so I copied it to the beaglebone. So you can see here the LED.exe. I copied it to the beaglebone. I'm gonna execute it. It's really simple. LED.exe. Yes, we should see the file blink the LED blinking for 5 times, and then the program closes. Now I'm gonna show, because I did it. I'm now gonna show from how the LED blinks in a video, in another video. In the same video, I'm gonna show how the LED blinks. I just wanted to show you here the screen so you can you could take a look, a clear look at the commands and at the code.
So now, as you can see here, this is my beaglebone. Here you can see the LED is turned on. Here I got you see the transistor because I'm turning on the LED by the means of a transistor. So we don't pull that much power from the beaglebone. You don't want to burn your beaglebone. So now I am going to run the program again, and the purpose of this video is you can see how the LED actually blinks 5 times as we set it on the software. Here I'm gonna show you my screen. Maybe you're able to see it. It's the same screen that you saw in the video. Here's I'm going to execute the same program as you can see there. So just hit enter. So here we got the LED blinking. It's gonna blink for 5 times only. See, so it already, the program already stopped. So I'm gonna do it one more time in order to, but just pointing out to the LED so you can see how it blinks the 5 times. I just wanted to show you the screen so you know that it's me that I'm doing the work, and it's my LED, and my code was actually working together with the beaglebone. Here we got the beaglebone working, connected to my computer. There we can see here you can see the transistor and 2 resistance. I got one connected, 100 ohms resistance connected to the LED, and another resistance of 10K connected to the base of the transistor. So what we basically are doing is this pin is connected to this wire. This is the pin that we are accessing. Is connected to the face of the beaglebone. You know how the transistor works. We're providing power with this green wire. We're providing power with this green wire and connecting it to the LED. So if we put a 1 here, so the LED is turned on. If we put a 0 here, the LED is off. So we draw is like a switch. The transistor is behaving like a switch. You know, pretty simple electronics. So we're gonna hit the keyboard one more time. It should start blinking. So it stopped. It stopped. See, as you can see, it was 5 times. I want to give thank you all for watching the video. And again, this is a video for my senior class at FIU, embedded Linux operating systems with Professor Alexander Pons. My name is Ernesto Fiayo. I hope you all learn a little bit about working with GPIOs. Thank you.